There's a lot of you. All right, so this is a talk about automating your software delivery pipeline, specifically with GitHub and using continuous integration services like Travis CI. I'm a developer at GitHub. I've been there for a little over 4 years. Most of my time there has been spent on internal automation, specifically around our testing and deployment. It was an area that I saw that we weren't operating very well with when I started, and so it was a natural place for me to dig in. I'm Atmos on GitHub and Twitter. If you want to find me later or email me or anything like that, I'm there. But I've been helping developers get their code running in production for about 10 years. And the thing about this is that everybody kind of builds their stuff and then throws it out, and it's kind of this terrifying act that people don't really know how to do well. And there's always like 1 or 2 people in the organization who know how to it looks really sketchy and it gets out and it sort of settles. And when I started out, we had a release process that required people to be in meetings. So we had this thing called a change control board. And so on Friday afternoons, like 6 or 8 people would get together and they'd discuss the changes that we'd had that week. And we'd be running all these integrated stress tests, and we'd say, oh, well, it doesn't look like it's killing the servers. But we had this weird thing where it was released by committee. And for me, that seemed really, really strange. And when I was an operations person at that point, and I was helping the developers get their code out. And they would email me through an internal system that we had at the organization I was at, a Microsoft Word document with step-by-step instructions of how I was supposed to compile these Java applications and then copy it into these places. And the devs would be like, dude, it totally works. You can see it in this environment. And I would say, well, I followed your instructions, and it's not working. And this is why we kind of make you go through all these steps. And the worst part of all of it was because I had to deploy on Sunday. Since I was the person who pushed the code out after the after the change control board on Friday, my Sundays were terrible because we deployed at 6 a.m. And I hated this. And I knew that there had to be a better way for us to get the code out. And I had a programming background, but was doing lots of ops at the time. And so I started automating it. I would take those MS Word documents that I hated, and I would turn them into a shell script. And the next time they came to me, I would say, hey, has anything changed? And I was able to work with the developers in that way. And they still sent me the Microsoft Word documents. But when it came time for me to go and do the code, I had my own little repository of the scripts that I was using to build all these applications. But things got better when I did it this way. But we still had the change control board. And we still had this culture of reviewing all of these things before the code went out. And the reality was that despite the fact that we could get the code out, the organization wasn't ready. And a lot of organizations aren't ready for a lot of the more advanced strategies that people are doing right now. But at the time, they weren't going to change. And so 10 years later, there's DevOps. There's all the crazy stuff that Amazon has announced this week, just alone. And it's interesting to see how our tools have evolved and how, in this day and age, I don't get Microsoft Word documents, but I may get a YAML manifest or something like that. And so today I'm going to talk about a few different ways that we can approach a software delivery pipeline in an automated fashion. And they can be adopted gradually so your organization is comfortable with them, but they can greatly improve the productivity of your team. And so you don't have to be all in at the beginning. While some of the more advanced things here are not for everybody, you can go little by little. And so what this happens is you can turn these experiences into little products that, there's scripts. I'm going to be talking about, building scripting, taking advantages of testing, evaluating things in production by deploying branches, doing all of this out of chat, and then in the end, having a system that's ready to be auto-deployed. And so there's a lot of buzzwords in this area. A lot of people want to, sell you something that's going to get you there faster. But the reality is we want to be able to deliver code. And this might be something that's compiled on the server. This might be checked out. But we're taking somebody's repository and getting it onto a server and getting it into an executable state. And so this is basically an app repository where all your code lives. A specific revision, which version of your code needs to go out. And in a lot of cases, it's called an environment. A lot of people say, oh, I'm deploying to production, or don't deploy to production on Friday. And so that's kind of the space there. With continuous integration, you have a test suite. So you test your code as often as possible. So every commit that goes into your repo, you test. So you know when things broke and when they didn't. And it allows you to feel more confident about the smaller changes that you're making in your system. And so there's a lot of options in this place. I've been using Travis CI a bunch and testing it with our enterprise instance, but there's like Jenkins, CloudBees, cruise control and stuff. And it really doesn't matter what you're doing or what you're using, as long as you're testing a lot and testing everything that you're doing. And this is basically the best first step that you can make towards getting things going if you're just compiling your app and throwing it out onto servers. Getting your testing stuff in order will allow you to improve. And it won't be perfect at first, but you'll learn from your mistakes and learn how to safeguard from those things in the future. And then there's continuous delivery, which is pretty popular right now because it's one of the safer ways for you to get your code into a running system without a lot of interaction from people manually. And so the goal there is that you can deliver code that's tested as successful to a production-like environment. So you don't have to worry about taking production down with the new code. You're able to get it into a place where you can do a full set of real tests on it before you push it out. And the interesting thing there is that you have gatekeepers. So you still have something like that change control board that I was talking about earlier, but somebody has to push the button. And for a lot of organizations, they want that. They don't trust these systems yet, and so there's somebody who goes in and says, yep, check it off, we're good to go. And so it's a lot less risky. And so it enables automation to be built and taken advantage of without running the risk of possibly pushing out stuff to production that takes down your site. Then there's continuous deployment, which is a little bit different in the sense that there is no gatekeeper anymore. When things are verified and tested and ready to go, there's no batching to a staging environment. It's just like all of the systems said, thumbs up, let's send it right out. And this is obviously more risky, but this is an approach we take at GitHub. When master branch is green, it goes out. And we have definitely screwed up a few times doing that, but we've been able to learn from those experiences and realize that this is a much better approach for us in the way that we all approach these talks. So just to reiterate here, continuous delivery, the last step is manual. Continuous deployment, it's automated, but your code goes through all of your testing cycles, and just keep that in mind. So the deployment basics, in order to adopt these technologies, you have to have a few things, and they're kind of frustrating to get right at first, but once you do, they'll be in a lot better shape. At GitHub, we have the rule of you can deploy anytime. And that means that if I wake up and feel like deploying the master branch, I can jump into our chat room and say, deploy GitHub, and it goes out, and it's the site that everybody uses every day. And that actually turns out to be a really powerful concept, because there's obviously situations where somebody's going to get mad if I do that, because they're testing something or something like that. But it means that in any case, if any changes are introduced to the system, we should be able to deploy. And that leads you to building a reliable deployment system. If you have 1 out of 5 or 1 out of 10 deployments failing for connection errors or other weird things, you're gonna actually have problems with it. And then you have things like, can all the developers on the team deploy? Do they need to be on the VPN? What happens if the network connection dies while they're deploying? What happens if 2 people both deploy at the same time? You need to understand these situations. And what happens, why should you go through all these really weird and restrictive processes if somebody's just trying to get a copy change out? If you go and look at your About page and it's like, we need to update it for the new person, it's like, we have to go through this huge process. It's like, no, we should just be able to get this stuff out. And this gives you less ops reliance. And this doesn't mean that you don't need really talented people to help you operate your infrastructure. What this means is that you don't go bugging 1 or 2 people inside your organization to get your code out onto the servers. You should let them worry about taking care of the health of the infrastructure, and you should be responsible for making sure that your code gets onto the servers in a reliable and repeatable way. And what this requires is you to have like some understanding about the boundary conditions of your application. Most of the things that we're using now, we have like CDNs, a few databases, local caching mechanisms, and all sorts of different things. And you need to understand how your software is going to interact with that and build cases for all of those to fail and for things to be resilient in all of those integrations. And what you get with this inside of an organization is a consistent process that you can start to adopt more widely inside your organization, and people can switch teams and still feel really effective. And there's nothing more frustrating than switching to a team and saying like, well, we only do this once a week, or we do this every couple of days. Just being able to switch around inside your org and know that everybody's operating the same way turns out to be pretty powerful. And this really gives you the situation where you can empower developers. Developers feeling comfortable introducing change into a system. Operating things won't always be perfect, but it just means that you'll be able to allow developers to do their job and really create things. And this just gets your changes out there faster to market. I mean, it's a competitive advantage to be able to get code out and in front of people. And so we have, when you start looking at automating your deployments, what most people usually end up doing is scripting. And so what you'll have is Capistrano or Fabric or Shell and SSH or the AWS CLI. And these always have really crazy complicated permissions requirements. You need to have SSH and or be on VPN and or have an IAM user that can do this thing on all of the servers required. And it starts to become a weird, fragile thing. And as your organization grows, it becomes kind of important to have a service there that allows you to unify the varying approaches that you're taking to delivering this software. And for us, it was to build a web API that allowed us to implement a consistent interface across all of the different ways that we were delivering code. And our service actually came out of a case where one of my coworkers couldn't stay connected to VPN. And every day he would say, Corey, will you push this out? And I'd have to stop what I was doing and go help him. And after a while, I was like, I'm just going to do something for you that is inside VPN, and you can hit it via a simple web API. And we came up with a way to trigger that through chat via our chat robot called Hubot. And so now that we had a web API that was doing all of our Capistrano integrations, we were able to go into our chat and have the robot make the connection to things. So the robot has all the credentials to make the HTTP call, and everybody who's in the chat is suddenly empowered to be able to go and, it's not my phone, is able to be in chat and do a deployment. So we started doing chat deployment. And what was cool about that is we had it all in one place then. We didn't have like the shell history in somebody's terminal who is done for the day. We had a link inside of chat, and so everybody knows every time that code goes out. And so I can, in this case, I'm deploying an application called Camo to both production and staging, and the little number 117 and 118 link to the output from the execution. And this has turned out to be great for us because we have people who can come in on their first day who are designers or engineers or front-end people, and they don't have to worry about even being set up to get on all the servers. They can go straight to the website, make some changes, and then ship it right out. And it's been really, really rad for us to see new employees come in and say, oh my gosh, I fixed that bug the first day. I've been bothered by it for 6 months, and I was able to. And so what this led us to do is taking that service that we were doing with Hubot and wrapping up all our scripts. And so what we've designed is a new API that allows us to trigger deployments regardless of implementation. So in the same way that we're integrating with other chat services and stuff like that, we have a new API that looks a little like this. And so our tooling in this case is Hubot for chat. He creates a deployment, and GitHub gives you the thumbs up like, yep, you did. And so GitHub at that point allows you to trigger something in a third party. Let's say that's something like code deploy. And the third party can go out, log into your server, do all of the things that you need to change, and then say, all right, man, I finished. This is cool. So the third party gets back to GitHub, and then GitHub can get back to the tooling. And this turns out to be really, really cool because this allows us to evaluate different deployment systems on a per repository basis. So as you're evaluating new systems, you don't have to take everything in your organization and switch it over to code deploy in a day. You can just start trying it for one thing. And for us, this is really good because the service that we've built is an all-or-nothing type of everything that we're deploying with it is there. And so it's been difficult for us to slowly wean ourselves onto more sophisticated systems. And so we have a plugin for Hubot, which is an open source chat robot that we have that supports like Slack and IRC and Campfire and FlowDoc and a bunch of other things. And so what we have is a little plugin for Hubot deploy that ties right into this deployment strategy through GitHub. And so this is, yeah, basically the same one from before, which is deploying camo to production. And the same thing with staging. And what's cool is this will take you straight, those links take you straight into code deploy. And you can see that I'm deploying an application, one of 3 instances is completed. And the way that they've structured things with code deploy, they've given this, and you can see like the deployment config is like one at a time. So you can do things like deploy to one server at a time and watch it go out. And if anything goes wrong, it stops you. Whereas if it's something that you're comfortable with and you just want to get it out quickly, you can deploy to all of them all at once. But it's something that you can tailor on a per application basis. And so there's a little config file that your robot would be looking at. And this is an ops work example that was previous to the code deploy stuff. But with this Hubot deploy thing, you can look, the repository is under the organizations called Legions, Camo. There's 2 environments called production and staging. If you're using GitHub Enterprise, it integrates directly with GitHub Enterprise. You just tell it the API token and the API endpoint. And then you can give it, if you're on OpsWorks, the app ID or the stack ID. And what's cool with the code deploy stuff is it maps up pretty closely with the deployment system that is part of our deployments API, where it's really just an environment and an application name and a revision. And so I'm pretty happy with that. So there's code review. Code review isn't a new concept. We had the change control thing that I was talking about earlier. The Linux kernel emails diffs around to each other, and that's their code review process with sign-offs. But the important thing is that other people are involved in the changes that you're making. And so we have a thing that we've called GitHub Flow, and it's our simplest workflow. And it's basically, since branching is cheap in Git, anytime you're making a change, you just make a branch. And by this, you can introduce changes that you can discuss, share with other people, and most likely won't be deployed accidentally. And then we have a thing called a pull request, which is a big way for people to have in a single place all of the latest code changes. And say I were to email Josh a diff for Travis CI, and I changed a few things before Josh even woke up because he's in New Zealand. I'd have to send him another one, and Josh might have read and made extensive comments on that outdated diff, and it's a whole lot easier when it's centralized inside of a web page. So this is a really simple example of me changing the Hubot that I was using, and all I'm doing is deleting a Hubot script, but you can see that all is well. We'll be talking about tests in a second, but what you do next is you get a coworker to sign off. And so in the same way that we were reviewing in the old days, oftentimes things are discussed in the pull request and things can be merged or rejected. And so in this case, somebody else popped in and they were like, I don't like that script either. And the pull request is merged and everything's good. And from a single button in the UI, you don't have to understand how to merge in this person's thing. You don't have to care about if they're on a fork or a weird different branch. The button does it all for you. And I'm able to go in, delete the branch, see that it's all there, and I can even restore it if I accidentally did it. And then we deploy the master branch. So at that point, new code is in the master branch. The master branch, like I was saying earlier, is always able to be deployed. And so that new code can go out. And so you can just switch back to Hubot. And so now when you start looking at that pull request flow and you think about how continuous integration works with it, I'm going to assume that most of your applications have, if they're business applications, have a test suite right now, whether you run it manually or not. But it's there to help you verify the behavior and correctness of your system. And we've all seen situations like this where it's like, I swear it compiled when I checked it in, but the source control system must have messed it up. But the thing is the continuous integration system becomes like it helps you verify the behavior, and it's sort of an impartial third party, where if it works on my machine but not on Josh's, or it works on my machine and Josh's but not CI, we're probably going to have problems. And so it helps you early on get the feedback that you need that allows you to have repeatable steps outside of a developer's laptop. And so you get a pretty good peace of mind out of this. It doesn't mean that everything is going to be perfect, but when you start to look at testing all of these small changes, you're able to look at the change sets and understand why certain erroneous behaviors were introduced when it's not a week's worth of everybody in the company's changes trying to nail down this one weird bug that's been introduced. And this is not only, when you're looking at deploying this code, not only did someone actually review it, but it was run and it behaved as intended. And so a few years ago, we realized that teams were really relying heavily on CI services, and we wanted to work it into code review. So similarly to the deployments API, we started having statuses that help with people going back and forth. And so it's actually a really simple model where the user pushes code, GitHub sends an event off to a CI system like Travis. Travis runs the code, sends it back. And inside of GitHub, that specific SHA is tagged as being successful or failed. And so when I go into the pull request, I'm able to look and say, oh, well, it passed. That's good, And that gives me a little more confidence when I go to click the button to get that branch merged into master. And so we also noticed that sometimes people have multiple services. So say I want one that's doing my browser testing and one that's doing my unit testing, and they aren't necessarily dependent on each other for whether or not it's evaluated. So when these statuses come back, you can actually tag them as status contexts. So in the Travis case, it'll come back and it'll say like continuous integration Travis CI. And then you can actually start to look at multiple systems coming back and reason about those and say, well, the browser testing passed, the unit test passed, but that new version of the VM that we're thinking about upgrading to, yeah, it's still broken. But that one's not important, so we can bypass it. But this allows you to get what I'm calling the enhanced GitHub flow. And so it's basically the exact same one as before, but the UI reflecting and relying on the changes to be there. And so, yep. And in this one, you can see down in the all is well, Travis CI build passed, and the details link. The details link is actually really cool because Travis is passing that back to us. And right from the code review, I can dive into Travis and look and see, oh, well, number 39 passed for that SHA. So, or if it failed, I don't have to go digging very far to find the build output to view whether or not or what I need to do next in order to get the build working. And so, if tests fail, it's easy to identify things right inside the pull request. People comment, commit, verify tests, iterate on it. And so what's cool about the pull request model is that while normally the master branch going out is really powerful, what do you do if you have to roll back after the master branch goes out because you just merged in something bad? And so something that we started doing a few years ago was deploying branches. And so what I have in this one, this should be, yeah, so it's like deploy Hubot add define script, and he's deploying the branch. So what that's allowing me to do is using the deployments API and Travis to verify that the tests pass, I can get that add define script branch out in production and say, oh, wow, well, it's working. So now I feel a whole lot better because I saw it working in production and there wasn't anything catastrophic. And if anything catastrophic had happened, I would have been able to deploy Hubot on the master branch and know that I could go back to that good state very, very quickly because that one has already been out and all the code's there. And what's cool is you also see them inside your pull requests. So you can see almost deployed to production a minute ago. So while you're going through and reviewing these things, you know, well, the tests are passing. It's been out in production for an hour, or in this case, a minute. You know, it gives you a whole lot of things. And so the rollback strategy is always a good example of this because most people don't know how to unmerge unmerge things. I always have to look it up. You know, and what if you can't, you know, undo it? But what about performance problems? You know, in a lot of cases, when you're trying to change code to debug a performance problem in your application, maybe you need to iterate on it a little bit before you know whether things are good. Or maybe you're going to push some code out that is actually worse than beforehand. And you need to try it to see how it's actually performing and behaving in production. What happens if error rates go up? What if your exception notifier is just, you know, screaming? This branch deploy allows you to look at things and use your metrics and your monitoring to give you a heads up earlier on in the process. And what if you need to revert a pull request? And the cool thing is that it enables experiments. And so branch deployments are all about minimizing the context for developers to evaluate code with a simple rollback strategy and redeploying the master branch. And in a lot of cases, staging and things like that are difficult for, you know, replicating production workload. Everybody kind of like has a staging box, but you know, when you have a significant number of users, sometimes it's difficult. And so here's an example of a pull request that one of my coworkers did, Charlie, where he was realizing that the method was already really fast, and we're doing all of this weird caching that was complicating things. And so you can see that he CC'd a couple people who usually come in to talk to him about it, and I can see that, you know, he deployed it, and that a whole bunch of people went by and talked about it. It's usually, I had to go back and find one, but it's usually kind of better when you're going through there. And yeah, and so the main difference is that you get to try and evaluate this code out in production since you have a reliable way to keep all of this going. And so that's basically the branch deploy flow. And so yeah, here's another one where I can just see that, you know, Josh left this out in production. So he deployed it twice. He actually took advantage of the deployments API, which when you go to deploy a branch says, oh, you're behind the master branch. Let me sync you up with the master branch because you should be caught up to that anyway because that's our, you know, agreed upon good state. And so what happened is it went ahead and deployed it for him after him, but he waited an hour and left it out there so he could keep an eye on our metrics, keep an eye on our error rates, and know that everything was good. And then you can see that, you know, he went ahead and merged it in. And so, you know, if performance looked good and tests pass and the teams agree on it, things get merged. And then there's GitHub Auto-Deploy. So when we think back to that continuous deployment stuff from earlier, I've started adding it into the site with one of our services that allows you to ship your code automatically. And this is crazy and cropped, but it's in the webhooks and services section of things. And so this uses the status API automatically for you and allows you to list out the different contexts that you want to test to make sure certain criteria are met before your auto deployments are created. And if you have a few, you can just comma delimit them. And so that creates a deployment in the system for you every time that criteria is met. And so say you only want to do continuous delivery. You can specify that the environment is just staging. Or say you want it to go to production and staging. You can just comma delimit production and staging there too. And so this gives you a really cool way to use the deployments API for whatever service you're using to deliver your application code and your continuous integration system to verify that all the code's good. And so yeah, so you can get continuous delivery with it, even for non-production environments. And then, you know, it provides continuous deployment too if you want to specify the production. And so it kind of looks like this, where the developer goes ahead and merges to the default branch, which is usually master, CI server event, hits GitHub back, everything looks good, auto deployment gets triggered, GitHub says, all right, deployment service, go out and do your thing. Deployment service goes ahead, delivers the executable code to your service, gets back to the system, developer knows, back in chat, you know that all of this has happened from the simple task of merging your code in and relying on all of these services to verify that things are good, and these are all pluggable via the API. So it's actually, yeah, so this is auto-deploy in action. So the pull request was closed. You can see 2 commits landing in the master branch. I actually deleted that branch. Travis came through, notified that the master branch was good. It took 10 seconds. Deploy number 119 goes out. And this doesn't require anything, where when you think about all of the complications of like going to 3 different systems and verifying everything, creating a script to do it, making sure that you have the right version checked out, it's kind of nice to have to not rely upon that. And so there's a few other approaches that you can do with this too, with the chat deploy things, where you can do things like environment locks. So I can say, hey, when Josh was testing that performance-related pull request earlier, he can say lock production. And nobody can deploy over him unless they explicitly say unlock, like really, really do it, Hubot. Or Josh either merges or unlocks it himself. And so what that allows us is, when I would wake up to go deploy first thing in the morning, I can say, oh, deploy, and it'll say, Corey, no, you can't. Josh is still testing stuff, and it comes with a nice little message where Josh hopefully has told us why he's locked it. And the service validation stuff in code deploy is actually one of the coolest things I've seen in a while, mainly because we don't have it. And I like it a lot because what we have are little triggers that run and monitor error rates and metrics and will yell at us in chat, but they're not a part of the whole deployment process, where those things might take 3 to 5 minutes to execute. I might want to know whether or not I can still log into the website, whether or not users can still sign up, whether or not error rates have escalated. And what this allows you to do is have little sets of scripts that allow you to go back and say, OK, yeah, verify functional test, verify new user signups, and make sure that it happens within 10 minutes. And so these little bits allow you to make it a much more advanced workflow where it becomes not only did all the tests pass and did the code get to the computers on whatever service I'm using, but is production really doing what it should? And this is also something that you can grow with your application, and and it allows you to test whether or not new code works, whether or not the error rates are elevated. Is it how isolated are these error rates? Is it just one user who happens to be hitting something, and like maybe there's corrupt data somewhere that person's only hitting, or is it widespread across the company or across the application? So this is exciting stuff. And I think that there's another talk later today it's more in depth about the code deploy stuff. There's also continuous branch deployments, which are kind of a way of, when you do a branch deployment, sometimes you may be evaluating performance or something like that, and you want to make a small tweak. When you push to that branch again, the deployment system can actually be aware enough to say, oh, well, that branch was out, and there's new commits on it. It passed all the tests. Let's ship it again. So you can get continuous deployment of your branches as well with a little bit of sophistication in there. And we've built it, but it's basically in one of our internal apps, and I don't know of many other people doing it. But yeah, that's another thing about discussing performance, because that's part of the wonders of the schema changes. So schema changes are crazy, because when you start having these models of automated deployment and database migrations and adding or removing columns, you need to actually think about how this is going to happen. Is it OK to add a column to a relational database? What about deleting them? And when you have this process where doing deployments is a whole lot easier, it's very easy to break your schema changes out into one deployment without any code using the new schema, and then follow it up with a subsequent deployment where the database is in the state that you want, and you can start taking advantage of that. And that's a whole, it's actually kind of complicated, but we use it a lot, and that's probably somebody could talk about that for a while, because deleting things becomes very problematic. But so there's so much going on right now that I hope that thinking about plugging these systems together in this way will be super beneficial to you guys. And you can do it with code deploy, you can do it with Travis, you can do it with GitHub. But regardless of the services that you're using, there's an API there that we're supporting these types of interactions. And so if you can think about it, you can build this type of integration with just about anything. If it's on your own homegrown system that you have for testing your deployment, it should work with this. And if not, you should be able to just go test it in the GitHub webhooks and services stuff. So this is all basically like helping deliver. I think there was something in the keynote this morning where I feel like developers care less and less about how the code actually gets on the servers. What they want is to be able to see their changes exist on the servers. That doesn't mean that they don't need to be smart about understanding how their code is behaving on those servers, but the actual action of getting code onto servers, people just don't really care. And so thanks so much. I'm going to see, I think I have another 5 or 10 minutes, and I'm going to see if I can show you guys some of this. They're pretty simple examples, but since it's a live demo, it'll probably blow up. Where's my browser? Do I have Wi-Fi? Oh, I don't have network. Yeah, I could be. It's giving the same thing. Yeah, I don't have a thing for wired network. Oh, is that on this? What is it? F? At? You know. Yeah, okay. So let's see if this works. All right, cool. So what I have here is, and the webhooks and deployment stuff, this is what it kind of looks like when you've got it all configured. So I'm using AWS Code Deploy. I've got Travis CI running on Travis Pro, auto-deployment, and a Slack chat room, which I'm using to test these things. And so I can go in, and this is just like a simple static site that's useful for this. And I can do inline editing. So, so many people watch me type. And I should be able to see commit come through in a second. I'll retry now. There it is. All right, so that's what I just dropped in place. I should be able to, in about 20 seconds, see another, like, Travis come through. Hopefully. Let's see where it is. Oh, yeah, it's running. Okay. All right, so that passed. And we should see in a couple seconds. So what just happened in that big loop there is the CI system got back to us. Since we have the auto-deployment feature enabled on GitHub in my webhooks and services, since this is enabled, just so you can see what the UI looks like. One password, why are you failing? You know, I can see that the production environment's going to go out and that I'm deploying on status. If you don't check status, it'll actually auto-deploy the master branch for you anytime you push. But you most likely want tests. So, yeah, I can see right here that the production deployment of my demo is done. And I'm probably going to have to log back in. Nope. And so this takes me right into code deploy. And you can see that it's done 2 of my 3 instances thus far. And with that, I'm going to guess that I can refresh this. And the code that I just changed is automatically available on the servers there. And so, you know, I didn't have to do anything complicated. The other thing which might be fun to do, let's see how well this goes. Create a branch. Hi, Josh. So now I'm in a branch. This is not right. It should be hi, Josh. This one's behind. I want a different branch. Yeah. All right. Now I'm in a branch called Hi Josh. And Josh is here from Travis if you're curious about it. You should talk to him. Let's see how this one works. All right, so my branch is there. You can see in the chat that Hi Josh is all good. In a couple of seconds, Josh is going to pass, what is this called? Demo. And so I'm going to be able to just say deploy this branch because now that the CI is passed, oh, I should have done it so I can show you that it yells at you and requires you to have it, the context there. So cool. So that just kicked off. So lets me go back to this. I can see that this SHA that I just committed, this is actually what it looks like in there. These map up to the GitHub SHAs. Is this the right one? Am I in the right branch? Yeah. So the unmet requirements. Yeah, it's mad at me because CI hadn't finished. All right, I don't care anymore. You can actually just say, I don't care, and give it a bang. So you can, sometimes your CI system's being dumb, and you have to be smarter than it. Or you're just waiting on things. But yeah, congratulations, Josh, on being awesome. So you can bounce around and try all these different things, and I can just go back and that's about it. So that's kind of how all this stuff works. Check it out. Thanks.